This lesson is about solving quadratic equations using the quadratic formula. And so far we have learned how to solve by factoring, solve using the square root property, where we have solved by completing the square, and now we will solve by using the quadratic formula. Now, I wanted to just show you where the formula comes from because I feel like it's important to see that. This is all kind of scrunched together here, but this is how you derive the quadratic formula, and it comes from taking the standard equation of a standard quadratic equation, and then completing the square, right? So that's where you take, divide out the a, take half of the middle term and square it. We're going to add it to both sides and so on. And then once you work your way all the way through it and solve for x, you get the quadratic formula. Now, you do need to learn this formula and know it, and you will see that I have it on each slide as we progress through this lesson. So here's the quadratic formula, and the a, b, and c come from, right, the coefficient of the x squared term, the coefficient of your x term, and your constant term. You need to be super careful with your signs so that you don't mess anything up that way. Now, I like to list these out at least at first, because if you decide to put these in your formula and you drop your sign, say on the -12, then that changes everything. Now I like to find the part under the radical first, which is b squared minus 4ac. All right. So if I take b squared, that's 11 squared, minus 4 times 1 times -12. Now notice right here I have -4 and -12, so I'm going to be adding 121 plus 48, which gives me 169. Now I'm showing you now why I like to do it this way. Then I put everything in my formula. So then I'll say P equals negative b means the opposite of b, right? So that's going to be -11 plus or minus the square root of 169 divided by 2 times a, and a is 1, so it's simply going to be 2 times 1. Now we simplify where we can. This happens to be a perfect square, so the square root of 169 is 13, and that's divided by 2. So this is one of those equations that would have factored, because you can see we're going to end up with rational answers on this. So that's -11 minus 13 divided by 2. Be careful how you do this, right? Because that's -24 divided by 2. So -24 divided by 2 is -12. And then we also will have -11 plus 13 divided by 2, which is 2 over 2, or 1. All right, so these are my two solutions. You can always go back and check your solutions in your original equation to make sure that both sides are equal. Okay, so it's okay to do that. In this case, when you plug in -12 or 1, you would get the left-hand side as 0, right? 0 equals 0, which is a true statement. Okay, so that's basically the lesson. The rest of this is all just practice. Practice using the formula, practice getting the b squared minus 4ac is also called the discriminant. The discriminant is that number that's under the radical. And so you want to practice getting that right. On this, my a is 1, b equals 5, and c is 3. So when I calculate b squared minus 4ac, and you guys, I would practice this and just make sure you get these right. A common mistake is to mess up on your sign, which changes the number. And then, of course, your solution is off because you did not have the right discriminant. So b squared, that's going to be 5 squared minus 4 times 1 times 3. A times c, right? 1 and 3. Which is 25 minus 12, or 13. Okay. Now I go back and put everything into the formula. So y equals, notice that the x can change to whatever variable you are using in your equation, whatever was in your equation, the one you're solving for. I'll get that out here in a minute. All right, so the opposite of b would be a negative 5. And that's plus or minus the square root of 13 over 2 times a, and that would be 2, right? 2 times 1 is 2. I'm just going to go ahead and write it that way because we actually have solved. We don't have any other simplifying to do, so that's it. That's our two solutions, right? Negative 5 minus 13 over 2, negative 5 plus, did I say the square? Negative 5 minus the square root of 13 over 2, or negative 5 plus the square root of 13 over 2. Okay. Now, when you are solving using the quadratic formula, then you have to have this in standard form, right? X squared minus 5x plus 8 equals 0. Remember, this is standard form for a quadratic equation. So you want to make sure that you have it set up this way, because if you leave it with one of your terms on the other side, then you may mess up your signs. All right, so a is 1, b is negative 5, and c is 8. Okay, and then I'm going to plug that into my b squared minus 4ac. Remember, that's just that part, right, the discriminant under the radical. So negative 5 squared. Also be careful when you square a negative. This will be 25, just like it was on the previous example. Minus 4 times 1 times 8. So this is 25 minus 32, or negative 7. So that is my number that's going to go under the radical. So x equals, the opposite of b would be a positive 5 plus or minus the square root of negative 7 over 2 times 1, which is 2. So this is 5 plus or minus I, radical 7. Remember, this is negative 1 times 7. The square root of negative 1 is I. And then that's over 2. Now, this could also be written, just so you know, 5 over 2 plus or minus square root of 7 over 2i. All right, and that would be the way you would write it if you separated those two terms in this way. Okay, next. Once again, we have to get the this equation set to equal to 0. And then identify your a, b, and c. Right? Being careful with your signs. So now I find b squared minus 4ac. So b is negative 9. Negative 9 squared will be a positive. Remember, when I square on this, every single time that's positive. Minus 4 times 11 times negative 1. All right, so 81, that's going to be plus 44 for a total of 125. And now I go to the formula. So n equals, the opposite of b would be a positive 9 plus or minus the square root of 125 over 2 times a, and a is 11. Okay, so I can simplify the 125 because that's 25 times 5. So this will be 9 plus or minus 5 radical 5. Remember, I'm going to bring out the 25. The square root of 25 is 5. And then my denominator is 22. Now at this point you would check, do I have any common factors? But 9, 5, and 22 don't have any common factors, so we stop right there and we have this solved. Okay, so that's it on that one. So on this, don't ever try to put fractions into your formula. Students try that sometimes, and most of the time they never get through the whole thing because it gets confusing when you have these fractions. So what would we do? Well, we would clear the fractions. We don't want to try to work with these kind of fractions. You multiply by the least common denominator or the least common multiple of your denominators, whatever you want to say on that, on both sides of your equation. So on 1/6 times 6 is 1, so that will just be x squared. Don't forget the negative 1x, so that'll be negative 6x. 1/3 of 6 is 2. And so we have that ready to go then. All right, so let's identify our A, B, and C. And then we're going to find b squared minus 4ac. So negative 6 squared minus 4 times 1 times 2. So that is 36 minus 8, which is 28. So there's my discriminant, 28. And x equals the opposite, right? Negative b means the opposite of b, so that's 6 plus or minus the square root of 28 over 2 times 1 for my denominator. And now we're going to simplify 28 because it's 4 times 7. So 6 plus or minus 2 radical 7 divided by 2. Now this does have a common factor, and you should always be on the lookout for this so that you do simplify this when needed. I'm going to factor out a 2, right? If I factor out a 2 of from my numerator, that's 3 plus or minus the square root of 7 over 2. And then I can remove that 2 because it equals 1. Oh, I forgot I made that line really big the other day when I was working on something. I'll use this one. So I can eliminate the 2's, and x is 3 plus or minus the square root of 7. And so that equation is solved. Trying to look at something here. All right, well, I'm going to stop this video here, and then we'll pick this up on the next video.